Also within the electromagnetic section or chapter is transformers. Several of you asked me to do this, so this is my attempt at drawing a transformer, right? So transformers are basically ways of changing the voltage within a circuit, all right? So there are two types. We call them step up and step down transformers, but they all work the same way. So they all have three parts, all right? One is that they have two coils of wire. So this is called the primary coil. Okay, and running through this circuit has to be alternating current. Otherwise, the whole thing doesn't work. Okay, so this whole thing is alternating current running through this, right? So, and running through this complete circuit with the primary coil. This is called the secondary coil. All right, so, and this also is going to have an output voltage or this is also going to be alternating current. And then within the middle, connecting the two coils, it has to be connected, is a soft magnetic material. Usually it's an iron core. And it has to be a soft magnetic material because, I'm going to put IE, it could be EG, but anyway, iron. Okay, it has an iron core because the idea is that, remember that soft magnetic materials pick up and lose the magnetism, the field of the magnet that they are being exposed to. So and remember that this is an alternating current, so the current is constantly changing. A changing current means a changing magnetic field, and so the idea is that this soft magnetic material, the iron core, will pick up those changes within the magnetic field, and then this over here on this side, you will also get a changing magnetic field, and that is going to induce a voltage in the secondary coil. I'm going to say that again, all right? So an alternating current means a constantly changing current, which means a constantly changing sorry, got distracted. Okay. Alternating current means a constantly changing current, which means a constantly changing magnetic field. Those changes in the magnetic field are picked up by the iron core. And so the idea is that over here, you also get a constantly changing magnetic field. Well, a constantly changing magnetic field induces voltage. We know this from the electromagnetic induction. So this induces a voltage in the secondary circuit, and you're going to get a voltage here. So why would you want to have a voltage here that just causes another voltage here? Well, that's why we have the step up and the step down. So you have step up transformers, which are going to increase the voltage, and you have step down transformers, which are going to, as they say, decrease the voltage. Now, how do they do that? It's all about the number of coils that you have. So step up transformers, all right, are going to have, if you're increasing the voltage, then the idea is that you have more coils in the secondary coil. I'm going to abbreviate that. In the secondary coil, whereas step down are going to have more coils in the primary coil. And there's an equation for that, of course. Oh, okay, just checking. You do have to have this equation memorized. So the equation that you have to have memorized is about the relationship between this, all right? So the idea is that the input voltage divided by the output voltage is equal to the number of turns on the primary coil, number of primary coil turns divided by the number of secondary coil turns. All right, a shorter way to write that is simply VP primary, okay, divided by VS secondary voltage equals NP divided by NS. Right, so that's the abbreviation. You do need to have this memorized, all right? And so that's the idea, is that you have transformers that step up, and the other thing, so they increase or decrease the voltage. Now, the other thing you need to think about is, what is that doing to the current? So usually, using our equation, V equals I Actually, hold on. Get a different page for this. All right. So if we assume 100% energy efficiency, so if the transform, which means that all of the energy from that primary circuit is being transferred to the secondary, which we know isn't true, but it doesn't matter. That's how you make the math simple. Okay. So if transformers are 100% efficient, that means that not only can we say what the not only do you know what the voltages are going to be, oh, sorry, you didn't see where I was pointing, right? The idea that this relationship can also give you the idea that, so if they're 100% efficient, then the input power has to equal the output power. And so what we talk about is that we say that the voltage times the current of the primary has to equal the voltage times the current of the secondary. Trying to look up whether you need to have that memorized. Yes, you do. Okay, so this is another equation that you should have memorized from this unit. So that's the idea. So in your world, in iGCSE world, the transformers will be 100% efficient. And so the idea is that the input power here, voltage times current, is going to equal the output power, the voltage times the current. All right. And so using this, you can determine, the idea is that if the voltage, so for step up transformers where you're increasing the voltage, if you're increasing the voltage, then you're going to decrease the current. All right. And the other way around. So step up transformers, here, sorry, go back here. Not only do they increase the voltage, but that means that by proxy, they are going to decrease the current. And here, if they decrease the voltage, then you are going to increase the current. So that is transformers. Oh, I don't know if there's a way for me to nicely show all this. Okay, there we go. That's as close as I can get.